Okay, we've got one last piece of this puzzle, unless I'm forgetting something, and that's going to be triggering our alarms. So our alarms are going to be triggered by these modes we've already got up here. We've got mode 4 and 5 for alarms, and those are low, low, and high, high respectively. So the first thing we want to do is we want to create triggers for our alarms. So we're going to take a compare block, equals, and we're going to be looking at the state int, and we want to know if that's equal to 4 for now. That's going to be on a one shot because again that's just going to be creating a trigger for the time being. So let's go ahead and take ONS 11, which is our next available address for one shots. And actually, we can call a one shot anything we want to, but I just like to call it something simple so that I can keep it out of my way later on. And then let's go ahead and create an alarm trigger. So this is going to be our low, low ALM trigger. Got it. And I can also, let's go ahead and create the data point for that. There we go. That's a Boolean in our main. Perfect. And I'm going to copy and paste this rung right here. And we're also going to be looking for that to be in state 5. So one more one shot. I know that's getting tiresome seeing me create one shots over and over again, but look on the bright side. You're going to know all about creating one shots by the time this is over. That's going to be our high, high alarm trigger, and let's just go ahead and create the data. So now we have a way to trigger our alarms, but we don't actually have alarms. Let's come down here, a new rung, and we know this is going to be controlling a digital device, in this case actually an alarm bit, but still. So we're going to go ahead and lay out our familiar digital control logic. We want an XIC to trigger it. We want a hold in to maintain it and an interrupt to get rid of it. And then we need the device itself that we're controlling. I'm not going to use notification bits in this program because, that's really not going to help us further our cause. So in this case, I am just going to use alarm bits. So to start with, we actually have a low, low alarm. I'm just going to leave it at that. And I'll go ahead and create that data. So there we go. And for this we could actually put that in controller scope because that's something that you might want to see pretty much everywhere, but just keeping it simple, I'm going to go ahead and leave it as such and put it in the program. And we need to bring our trigger down here to make this thing start. We've got the alarm bit itself as a hold in, and then the interrupt is going to be an alarm reset. So that'll be probably a push button on an HMI or a SCADA system somewhere. And we can go ahead and leave that as such. And then let's copy and paste that down here because we also need one for our high, high alarm. So there's our high, high alarm trigger. That's going to be HH alarm, which does not exist yet. So we'll have to create that. Our interrupt is still going to be the same alarm reset button. And then we can just come over here and that's it. So now we actually have alarm bits. We actually have triggers for those bits. We have devices which are going to be running based on them being in the proper mode. And one other thing that we can do, let's make sure none of our devices ever run by any means if we're in an alarm condition. So I'm going to come down here and let's create a branch, and we're looking at either of two conditions. That's going to be if we're in a low, low alarm or if we are in a high, high alarm. Then we want to energize a common bit that says alarm EXISTS. So that's just telling us that an alarm exists, and we'll go ahead and create that. And now let's come back up here to our pump and our valve, and we're going to have one more interrupt on here. Actually, I'm going to go ahead and put this off here, and that's going to be in series with even the trigger and the hold-in as well. And that's going to be our, actually we don't want that to be an XIC, we want that to be an XIO. So that's going to allow this thing to run as long as an alarm does not exist. So we've got the same thing on our pump and our valve. One other thing that we want to do, we need to manage our mode a little bit if we get slammed into an alarm condition. So if we go into an alarm, I want to go ahead and throw us back into start mode so that the system can reevaluate exactly where it is. So let's come up here and say, what do we want to do? What else is going to put us into start mode? We've already got the start button putting us into start mode. Let's create a branch and give ourselves one more possibility. And that's going to be if somebody presses the alarm reset button, and we don't want the alarm reset button if we're off. We don't want that to put us into start mode. And likewise, if we're not in an alarm condition, if we happen to be draining or filling the tank, we don't want that to put us back into start mode either. So we need one more set of conditions here, and that's going to be checking to see if our state is equal to one of our two alarm conditions, namely 4 or 5. So let's come over here and grab an EQU looking at state, and if our state is equal to 4, or if our state is equal to 5, so let's go ahead and come down here and drop in a 5 as well, then we want to one-shot ourselves and put ourselves back into mode 1. So at this point, I think we've got a finished project, at least in the ladder diagram alone. And we will come back in the next section and we'll put it to the test. We'll emulate this and see it working. We'll go through a few tests and make sure it's actually doing what we expect it to do. And if I've got any bugs in here, which is always a possibility, then we'll get them straightened out in the next lecture. So let's come back then and see if we can't make this thing start working.